I'll just write this. Okay, so what to expect for your final presentation. So everybody has scheduled some kind of time, an appointment with me next week for about 45 to 50 minutes. And what's going to happen is, your report is due at the time of your presentation. Okay, so if you've scheduled it for Monday, your report's due on Monday at the time of your presentation. And if you've scheduled it for Friday, then your report's due on Friday at the time of your presentation. Okay, so whenever you've scheduled it, that is when it's due. The grading of your report and presentation will happen during that 45-minute period of time. Okay, so I will spend that 45 minutes reading through your report, and I will grade it. The grading happens during your appointment. Okay. Your completed report can be either a Jupyter notebook published to GitHub, or you can save it as a PDF or HTML file or something. Okay, you can save it in some alternate format, that's fine. Okay, so final reports can be Jupyter notebooks or PDFs or some other format. It doesn't matter. Okay, and you will submit that to me at your presentation. The presentation will start with your appointment will start with your presentation. So I'll give you 5 to 7 minutes uninterrupted. You will start and you can do your presentation. Okay, how you've done your presentation is up to you. You can do slides if you want. If you don't want to do slides, you want to do something different, also fine. Okay, but and not everybody has to talk. It could just be one person or multiple people talking for about 5 to 7 minutes. Okay, so the appointment will begin with your presentation for about 5 to 7 minutes. Okay, and then after your presentation is done, I might have a couple questions, I might not. We might just go directly into reading your report. Okay, after the presentation, I might have a few questions or not. And it's neither a good sign nor a bad sign if I do or don't have questions immediately after your presentation. So don't worry about that. And then what we'll do is the rest of the time, the rest of your kind of appointment, so about 40 minutes, will just be spent reading through your report together. Okay, we'll spend the remaining 40 minutes or so reading through your report together. Okay, and I feel like spending 40 minutes reading through a report is enough time for me to give it a fair grade and evaluation. Okay, this is what I found myself spending. Last time we didn't have this appointment. It was just people submitted their reports and I read through them at home by myself, and I found myself spending around 30 to 40 minutes on each report reading through them, and I decided to schedule the appointments this way because I always had questions and I wanted to ask questions, and the students weren't there to answer them, and I had to just make a decision on like whether to deduct points or not. So it's going to be I'm going to read through the report, and I will ask questions as I read through your report, right? So we'll spend the remaining 40 minutes reading through your report together, and I will be grading your report at that time. As I have questions, I will ask them, and your responses will factor into the grade. Okay. All right. So questions will range from why did you decide this to why did you choose to do this, or why didn't you do this, things like that. And I'll also be providing feedback during that time as well, and I'll let you know that, like, you know, this was not an appropriate graph, or this was, or something during that time. Does that kind of make sense for how this is going to go? So whenever you're presenting, that's when your final report's due. You start off with your presentation just so I kind of get an idea of what to expect, and then we'll read through the report kind of together. I'll read through it, and I'll ask questions along the way, and that will be how I grade all of your final reports. Okay. A lot of you guys have come by to office hours with questions, and I've tried to provide some suggestions and ideas, and I'm excited for seeing what kind of projects you guys are coming up with, and what kind of analysis and things like that. Okay. Is that good? Any questions? And all right, that's it. And okay, I guess my suggestion is sometimes when you, maybe I'll edit this, and final reports can be Jupyter Notebooks or PDFs or some other format, and I would say I strongly recommend having a PDF version of the report as a backup, in case if you know your primary report will be a Jupyter Notebook. Okay, because sometimes you can write a Jupyter Notebook and put it on GitHub, and sometimes when you go to GitHub it will render the page correctly, but then sometimes GitHub will fail and it won't render the page and I can't read it. Okay, so I strongly recommend that you make a PDF version, like after you've rendered your report on your own computer, you know, download or save as PDF and keep that as kind of a backup, and you can just give that to me and I can just read through that as well. Okay. Because sometimes GitHub has trouble rendering notebooks. Okay, so that happens a lot. So just in case, I strongly recommend having a PDF version as a backup there. Okay, any questions? Is that good? All right, then oh, sorry, let me get Jupyter running and we'll talk SQL. Oh, and I guess, I don't know if this needs to be said. I guess this is our last lecture together. We're not going to have any lectures next week, okay? Because we're doing final reports and stuff. So, well, that's kind of sad. But, okay, yeah, so no class next week. I'll just be having different reports and final presentations and stuff. So I'll see you guys one more time during next week, but this will be our last time together as a class and lecture. Okay. I'm probably much more sad about it than you guys are. So thank you for always coming to class, you guys, right? I know there's like 80 students enrolled, and I don't know if, like, other than the first week, the class has not been full, but you guys have come consistently, so thank you. That always feels good. I think this is up, has been loaded to GitHub in case you want to follow along on your computer. I should get rid of these other old repositories. 9.2, yeah. So this is here. Okay. All right, so we load pandas, and we get SQL Alchemy, and then we can ask, what are our table names? So we're still working through the Chinook database, okay? And again, this is just kind of still like basic SQL functionality, okay? SQL, and I think it's enough to kind of do some baseline stuff. I know there was some drama involving DataCamp earlier in the quarter, and so I didn't force you guys to use it. I think I sent an update on it, and again, you can be the judge on whether you want to use DataCamp's services or not. Again, they gave everybody free 6-month subscriptions, and so it's still, I think your subscriptions are still valid and active, and so if you want to use it, that's up to you. They have taken some kind of disciplinary action. I think they've suspended their CEO, who is the one who was accused of the misconduct, and they're doing some investigations. And so you can decide if you're okay doing with that company. They do have a decent SQL tutorial as well, but the other stuff, I think in the first lab, I think my number one recommendation is indeed these exercises here at W3 Resource. Okay, but anyway, this is where we are, and we'll work through this. Okay, so here we started. This is just kind of selecting a few. Select everything out of here, and we're after we've created our engine to kind of connect to the database, we can just use pandas read SQL query, where we provide the command and provide the engine. And so all of everything here is just running these commands. And so here we're looking at select all the columns from the table album, and we're looking at the first 5 rows. We do the same thing for the artists table. And here I'm going to take a look at the invoice table, and the invoice table has a bunch of customer information, okay? And so we have an invoice ID and a customer ID, okay? And this is what our invoice table looks like. And then there's another table called invoice line, okay? So this is kind of like the overall invoice information, and then the invoice themselves have line items, okay? And so this is quite interesting. And this table showcases SQL's kind of philosophy of minimizing redundant information, okay? Because we might normally think that in our invoice we should include line items, okay? But SQL says that is going to produce redundant information, because every line item will have the same kind of customer information. So we don't want this information duplicated, and so we create a separate thing, and maybe let me I'm trying to find an invoice where somebody ordered multiple. Oh wait, yeah, I'm sorry. Okay, so on so lines 3, 4, 5, and 6 are all tied to invoice ID 2. Okay, so invoice ID 2 consists of these 4 items. Okay, at 99 cents, and these is the track ID. So we have track 6, 8, 10, and 12, and so that information gets is going to have to come from the track table. Okay, so we have to look up kind of track 6, which will be this, and this will be kind of the first item that that shows up here, okay? And so, so we have to kind of tie all of these things together. And then also here's the customer table itself, which the invoice table kind of identifies the invoice ID and the customer ID. And so this will allow us to look for, customers by their name and information, including kind of their first and last name and all of that stuff shows up in this, the customer table, okay? So there's all sorts of tables, and they're kind of linked by all of these ID columns, so that we're minimizing any kind of redundant information. Okay, and so this is a very complicated, I don't know about very complicated, but this is how we are going to join several, I guess this is just actually joining two tables together. So we're going to join the customer and the invoice table, all right? And this part, and this is also how you write comments in SQL. If you do a dash dash, then everything after that comes the dash dash is a comment here, okay? So what we have here is we're going to do select, and let's ignore this for a second, but we're going to select it from the customer table and the invoice table, okay? And I'm providing aliases before customer. So it used to be I would have to type out customer.firstname, customer.lastname to kind of identify this is the columns that I want. But here we're going to do customer as C and invoice as I, and then I can do, C.customerID is equal to I.customerID, and this is how we join the tables together. And then I can say, and I can specify the columns I want by doing C.firstname and C.lastname, I.invoiceID, I.invoicedate, and things like that, okay? And so this is a very common practice of like renaming your tables into something short so that you can kind of reference them easily, okay? And then in here I'm going to specify so this is saying I want these 1, 2, 3, 4, 5 columns, okay? So those are the columns I want. We provide aliases for the tables so we can kind of shortcut typing out each of these things. We specify how these two tables are linked together. We want to join the customer and invoice tables based on customer ID. And now I'm going to say I only want the ones where the country is Brazil, and I want the first 20 rows, okay? And so when I run that, I get this, and we see we have Luis Goncalves had made several orders, 7 different orders from Brazil, and then we also have Eduardo Martins, who made several orders, and Alexander Roca also has made several orders, okay? And these are all people from Brazil. Okay, here is, if you want to use get unique values, okay? You can do unique things, but it's called distinct, okay? So the keyword in SQL is distinct. So we're just going to say, select distinct billing countries from invoice, and this will provide just how many unique countries or distinct countries there are, and looks like we've got 24 of them. And this is what we've got. All right. These are all little problems that we're solving here. So here it says, provide a query that shows the invoices associated with each sales agent, and the resulting table should include the sales agent's full name. Each invoice has a customer, and each customer has a support rep. And so that's how we're going to identify kind of our sales table. Okay, and so so we're joining 3 tables together, okay? So we've got the invoice table, and we're joining it to customer, and we're also going to join kind of that table. So invoice is joined with customer, and we're going to join also this with the employee table, okay? So So the link is from our invoice table. If we, I guess I never showed the employee table, but the invoice table has a customer ID, and the customer table has a customer ID, so that's how we link those two together. And the employee customer table also has a support rep ID, okay? And this is how we match it with the employee ID, okay? And so these two get matched. So we're gonna say invoice as I, join customer as C on this thing. We're gonna look at the employee table, we're gonna rename that E, and we're gonna link it between the employee ID and the from the customer table, the support rep ID, okay? And that's how we link our tables together. And then we're gonna say we want the employee first name, employee last name, and then we're gonna get all the columns from the invoice table. So we can do I.star here, okay? So if you just do star, it's gonna return all the columns, but here it will do this, okay? And then we're gonna order by employee ID. Does that kind of make sense, how this query works? So this is how we can start linking, make more complicated queries by linking multiple tables together. Okay, and so we get first name, last name, and then we can get the invoice ID, customer ID, and all of this stuff. And so these are all things from the invoice table. Notice I didn't actually even select any of the like things from the customer table. If I wanted to, I can do C dot first name as customer first name, okay? And I think, and so now, and C dot last name as customer last name, right? Oops, I forgot a comma here. Okay. And so now we have information kind of on each of these invoices and stuff. Okay, so you can, so you don't have to, oh, and notice, again, SQL is not case sensitive. So even though I wrote first name all lowercase, in the table it's actually capital F, capital N for first name, and capital L for capital N for last name. But SQL doesn't get angry with me, okay? So you can do all sorts of stuff like this. And this is all sorted by employee. We're sorted by employee ID, but that's actually, you'll notice, that's not even one of the table values that show up in our table, because it's not something that we've requested in select. Okay, so again, here's kind of another thing. So we're renaming all of this. I guess I'll change this back. I guess all of this stuff shows up anyway. Okay, so over here, I've got select the employee first name as employee first, employee last name as employee last, customer first name, customer last, customer country, and invoice total. Okay, and then again we're joining the employee table to the customer table to the invoice table. Okay, and we're kind of specifying kind of the chain of how these tables are all linked together. Okay, and so we get all of this, even though, and the links work even though I didn't say I want to select employee ID and support rep ID, even though those columns themselves are not displayed here. Okay, the linking has happened, and it just returns the columns that you've requested in select. Okay, So it's we can ask how many invoices were there in 2011. What were the total sales for 2011? So for that one, we're going to ask. We're going to select invoice ID and total. We're going to just do invoice.I as I, and then to get 2011, we're going to do invoice date between, and then we kind of have to convert these into dates. Okay, if you're dealing with dates, you have to convert strings into dates, and so we're going to do from between 2011 and 2012. If I wanted to do, I think I can do invoice. What are the column names in invoice? Invoice date, okay? So this will kind of just verify that we want invoice date and total, okay? And so indeed we can see, our first invoice date is 2011-01-02, and then our last one is 2011-12-27, okay? And so it gives us 83 rows and 3 columns regarding the date time information. If we want the total sales for that year, okay, now we use these aggregate functions, okay? And so here basically we have this, the invoice ID and the invoice total, and we can just say count the invoice IDs as count and sum up the invoice totals as the sum, okay? And this part is exactly the same as before, and this will provide the where'd it go? Summary information there. Okay, so this is how you do kind of aggregation in SQL. Right? If we did something silly, okay, like if I did a group by on the invoice ID and I said count this, what are we going to get? We're going to just get ones here, okay? Because here it's going to do it's aggregating, you know, after grouping on invoice ID. Let me do select. I think I can do invoice I dot invoice date, and we can group by invoice date. Okay, and this will tell us, you know, kind of how many orders we had for each date. Okay, so that's one way to do it. If you wanted to, so this will count how many orders were made on each day, right? And so up here we had a total of 83 orders in 2011, and I guess we had 71 unique days. Okay, some days we had multiple orders, so we had 71 days where orders were made. Okay. If we wanted to, we can look at the invoice line table, and we can say provide a query that counts the number of lines for each invoice, right? So here, what we want, so if we just look at what our invoice line table looks like, we want to say invoice ID has two things, and invoice ID 2 has 1, 2, 3, 4. Okay, so how would we go about doing something like this? If we wanted to, so think about this. Looking at this table, let's get a query that counts the number of line items for each invoice. So we want to say invoice ID 1 had 2 items, 2 line items, and invoice 2 had 4 line items, and invoice 3 has, 4 line items or something. Okay, can you guys think of how we would write our query for this? We would select, so we'd probably select the invoice ID. It's not required, but you'd probably want to select the invoice ID, and then how do we get the kind of the summary? Okay, so what we would do is, we would say select the invoice ID, and then we would do a count of invoice, either invoice ID or invoice line item, it doesn't matter, and we're going to do kind of as count of line items, and then we're going to do a group by what? Invoice ID. We're going to group by invoice ID. Okay, so we're just going to do select invoice ID, count invoice line ID, okay, this column or whatever, as count, and then we're doing it from this table, invoice line, but we're grouping by invoice ID. Does that kind of make sense? So we go ahead and do that, and indeed we get what we want. So invoice 2 has 4 items, invoice 1 has 2. Invoice 5 had 14 items on it or something like that, okay? And so that forms our query right there. All right, is that all right for kind of aggregating this? Okay, I'm gonna just do like, maybe like 1 example or 2 examples of the common table expression, okay? And this is kind of you can look this up and you can ask what SQL CTEs, right? Common table expressions, and over here it says they're used to simplify complex joins and subqueries and things like that. So let me just kind of show you as this, okay? So we're creating, okay? We're creating a table within here. We're creating something called a table called invoice counts, right? So let me just show you what this command does here. Did I do that? Okay. So inside this, okay, I have this selection here that says select invoice ID, count invoice line ID as count from invoice line, group by invoice ID, and order by count descending. Okay, so this part is basically equivalent. Let me put in the order by, what was it? Order by count, descending, and then maybe I'll just do limit 10. Okay, just so we kind of have an idea of how this goes, right? So this part, this table up here, is pretty much what I've got going on here. Okay, select invoice ID, count invoice line ID as count, from invoice line, group by invoice ID, order by count descending. Okay, that's what I have in here. You guys see that? So this is an intermediate table that aggregates the invoice line IDs. Okay, it's pretty much the exact same table we generated in previous step. Okay, so we're going to do that, okay? And then basically what I want to then do, maybe I'll get rid of the limit 10, okay? Basically what I want to do is do an operation on this resulting table. I want to get kind of the biggest count, the 14, and the smallest count, which seems to be 1, okay? And so I'm going to rename this table that I just created here, okay? So this result here, we're going to basically rename that and call that invoice counts, okay? We're going to call this invoice counts, and there's basically two columns here, ID and count. Is that okay? So I'm taking this table that I've we could imagine we've created this table above, and we're calling this the invoice counts table. And then from this invoice counts table, I'm going to do an operation. I want to select the biggest count and the smallest count, max of the count and min of the count column. Okay? And so here it's basically saying select the max of the count and the min of the count as, maybe I'll just call this as max and as min or something, okay, from invoice counts. And basically what I'm doing is I'm taking the output of this table and we're calling this invoice count, okay? And which is right here. So we've created a table here. We're naming it invoice counts, and we do it by using this with invoice counts as, okay, which is a weird way to express this. You'd almost want to say like, make this and call it invoice counts or something, okay? But this is the terms that SQL uses. So you're going to say with, and you provide the name of the table and the the names of the columns in it, all right? And then you provide how this table should be created, okay? And then you do select whatever you want to select from it, from this table that we just named invoice counts. Does that kind of make sense, how this is working? So it allows us to basically create kind of these intermediate tables and kind of store the results of these tables and then do further operations on this thing, right? So what if, so another thing I can do is I can, what if I wanted to count how many orders had 14 items, how many orders had 13 items, or something like that? Okay, I can do that, but how would I do that with this table here? I would group by count, and then we would count how many invoice IDs there are, right? So we're going to do with invoice counts this, and we're going to select, so we're going to do a group by count, and what we want to do is we're going to select count, and then I hope this works, count of, what was it called? Count of ID as, I guess I'll call this how many had this many line items. All right. Oh no, it broke. What did I do? Select. Did I do something? Maybe I'll call this select. I don't think this is what I need to do. Select count group by. Okay, thank you. Sorry. Group space by, exactly, right. Okay, so we have 59 orders with 117 orders. This is strange. Okay, well, whoever created our artificial data set obviously likes the number 59. But this is kind of, I think this is kind of a neat thing that you can do, right? So you're creating kind of this intermediate table, and then you are aggregating you're doing some kind of operation on it based on that. Okay, and so that's called a common table expression. And like if you're able to do this, like in a SQL interview, like people will be like, wow, all right, we'll give you the SQL job. Okay. I don't know. Okay. I guess I'm patting myself on the back there. Okay. Here we say, make a query that includes the purchase track name and the artist name with each invoice line item. Okay. So the hardest part with this is how you're going to join all of these tables together. Okay. So we're looking at our invoice line table, which has all of these things. Okay. And the invoice line, we can link that to the track table, okay, based on track ID. We can join the track ID to the album table based on album ID, and we can join the album ID to the artist table based on artist ID, okay? And so the complex part is like, how do you join these tables together based on all of these things? And so we'll do that. And then this allows us to kind of look at the invoice line table and kind of join everything together. And this is what we get, right? So we get invoice line, invoice ID, and now we can figure out like, oh, this is the track and this is the artist. Okay, we could include the album name if we wanted to, but we didn't. Okay, and this is just something that goes, okay? Dog Eat Dog by AC/DC, okay. What did I do? One table is of products, another table is of sales. Assume product ID is the link. How do you find all the products that do not exist in the sales table? Oh, okay. So if you want to find things that don't exist in the other thing, you can do a join, like an outer join, and you can say where something is null. Okay, so here's kind of the Venn diagrams of all of these things. Okay, so here's so here is two tables. Okay, you got table A and table B. Okay, and we can join. We can link pirates show up in both, and ninja shows up in both. But we've got monkey and spaghetti in table A, and Rutabaga and Darth Vader in table D. Okay, so if we join them on the name, then we'll only get the values that are in common to both pirate and ninja. Okay, if you do an outer, then you'll get everything all together, and you'll get kind of nulls for these kind of the things that don't exist. And then here you can do the left join, and then over here, if you want the things that exist in A but not in B, you can do the left join, but you ask where table B is null, and this will give you kind of these values here. All right, and this is the one that this is the complex one. So I think this is a good resource to kind of just keep in the back of your mind there. Okay. And this is from way back in 2007, but SQL hasn't really changed much. SQL has been fairly stable. Like they don't really add too many features. Maybe some of these different flavors of SQL, but kind of your base things of SQL have remained fairly stable. And that's that. So we'll end there, and we will see you guys during your scheduled appointments for your final presentations. I look forward to them. Okay, well anyway, yeah, thank you guys. Oh, thank you. So,